So welcome to our session. Today we go to see linear partial differential equations of second and higher order with constant coefficients of homogeneous type. So the homogeneous linear partial differential equations. So a linear partial differential equations with constant coefficients in which all the partial derivatives of same order. So this is important. The same order. So any differential equations having the same order, so we call as the homogeneous partial differential equations. Otherwise, we call as non-homogeneous partial differential equations. So a homogeneous linear PDE of nth order with the constant coefficient is of the form a naught into dou power n by dou x power n. So a1 into dou power n z by dou x power n into dou y and so on is equal to f of x comma y. Here a1, a0, a1, a2 up to etc. an minus 1 and an are constants. That's why ai is a constant here. So equation 1 can be written in the form of 2. So that means here in this the whole unit we have to taken. So our capital D is nothing but dou divided by dou x and d square is dou square divided by dou x square and so on. Similarly, d dash means dou divided by dou x. Sorry, dou is by dou y. Therefore, whenever you have to taken as a capital D, so capital D means with respect to x, d dash means with respect to y. Similarly, d dash square is nothing but dou square by dou y square and so on. So d dash means nothing but, so for both the d, dou square divided by, this is for d and this is for d dash. So now f of d comma d dash into z of f of x comma y is equation number 1. The general solution of equation number 3 is complementary function plus particular integral. So the complementary function we have to take as the right hand side is 0. Therefore f of d comma d dash in z is equal to 0 and particular integral is equal to 1 by f of d comma d dash into f of x comma y. So the method of finding complementary functions. So now to find the auxiliary equations, we can replace d is equal to m and d dash is equal to 1. So we can get f of m comma 1 equal to 0. So therefore solve the equations we can get roots. Suppose the roots are non-repeated, so we can get complementary function is phi1 of y plus m1x plus phi2 of y plus m2x and up to etc. Phi n of y plus m1x. Suppose the set of roots are repeated. The remaining roots are not repeated means for the repeated roots we can write phi1 of y plus mx multiple 1x, phi2 of y plus mx. Again you multiple another x, we can get x square into so phi2 of y plus mx and so on. So this is the repeated roots. This is for the repeated roots. Type 1 is nothing but the right hand side is 0. So the first problem, solve 2r plus 5s minus 3t equal to 0. So the given partial differential equation is dou square z by dou x square. So instead of r we can replace dou square z by dou x square. Instead of s we can replace dou square z by dou x dou y. Instead of t we can replace dou square z by dou y square. So in this dou square by dou x square, we can replace d square z plus instead of this dou square dou divided by dou x dou y, we can replace d dash. Instead of this dou square by dou y square, we can replace d dash square. Therefore, once you replace that one and bring this z outside, we can get equation number 1. Therefore, this is the homogeneous partial differential equations. So replace d is equal to m and d dash is equal to 1. So we can get the auxiliary equations. So 2m square plus 5m minus m equal to 0. Therefore, we can solve this since it is quadratic equation. Solve this, we can get 2 roots 1 by 2 and minus 3. So since the roots are non-repeated, so we can take in the formula phi1 of y plus m1x plus phi2 of y plus m2x. So in the complementary function, replace the m1 and m2, we can get the complementary functions. So therefore, since the particular right hand side is 0, therefore particular integral is 0. So therefore, the complementary plus particular integral, we can write the solution. The general solution that is equal to phi 1 of y plus 1 by 2 into x plus phi 2 of y minus 3x. So the next problem, solve d square minus 2d d dash plus d dash square into z is equal to 0. The given partial differential equation taken as equation number 1. So the now since the given is a homogeneous linear partial differential equations, so replace d is equal to m, d dash is equal to 1. So we can get the auxiliary equations. So the auxiliary equation is m square minus 2m plus 1 equal to 0. Therefore, roots are 1 and 1, roots are repeated. So therefore, we can replace the roots, we can get complementary function. Since the RH is a 0, therefore particular integral is 0. Therefore, that is equal to complementary function plus particular integral. So therefore, that is equal to phi 1 of y plus x and x into phi 2 of y plus x. Similarly, this is that's all dq plus d dash plus minus d square d dash minus d dash cube, that is equal to 0. So taken as equation number 1, since it is homogeneous linear partial differential equations, we can replace d is equal to m and d dash is equal to 1. So the auxiliary equation is m cube minus m square plus m minus 1 equal to 0. So the solve this one, we can get three roots are there. So plus or minus I and 1. Therefore, roots are minus I plus I and 1 are the three roots. Therefore, replace your x is equal, m is equal to minus I and m is equal to I and m3 is equal to 1. We can get phi 1 of y minus ix plus phi 2 of y plus ix plus phi 3 of y plus x. So replace your general solution. Therefore, that is equal to this. So the next problem, the d power 4 minus d dash power 4 into z is equal to 0. The given partial differential equation is d power 4 minus d dash power 4 into z is equal to 0. Therefore, this is a homogeneous linear differential equation. So replace d is equal to m and d dash is equal to 1. So instead of d, we can replace m. Therefore, m power 4. So instead of d dash, we can replace 1. We can get 1 power 4. So the m power 4, we can take as m square the whole square minus 1 square. This is m a square minus b square formula. Therefore, we can replace a plus b, a minus b, and find the roots. The roots are plus or minus I and plus or minus 1. So since d power 4, so therefore we can get the power is 4, therefore we can get 4 roots are there. So m is equal to I minus I, 1 minus 1. So replace our complementary functions. Instead of m1, I can replace I. Instead of m2, I can replace minus I. m3, I can replace 1. m4, I can replace minus 1. So we get the complementary functions. So that is equal to complementary function plus particular integral. Since particular integral is 0, we can replace the complementary function. Therefore, that is equal to this. Thank you.